morning all of you, and let's try this beautiful problem. So usually the problem of J is motivated by telescopic series. Sometimes it has been seen like the basic idea of telescoping is inbuilt there in a very beautiful way. So let's see how we can solve this problem. So J is running from 1 to 2n plus 1. We have a given expression, and clearly n is a natural number which is not positive integers. So we need to find the value of this. As you can see, the summation is in the form of something cubed by something square minus 3 times of something plus again 3 times of something square. So just to simplify this, let's consider an expression b cubed by a square minus 3ab plus 3b square, where a and b are distinct real numbers, plus let's try to mimic the given sum with a minus b whole cube divided by a square minus 3a into a minus b plus 3 into a minus b whole square. Now before I go further, let me tell you the motivation behind this. As you know, in the usual summation series, we attempt to add the first term and the last term. For instance, a usual Gaussian sum s equals 1 plus 2 plus 3 plus 4 plus 5, suppose if you need to add. So the idea of arithmetic progression, logically it was, you reverse the series 5, 4, 3, 2, 1, and now you add them. So 2s equals 6 plus 6 will have 5 times, and hence answer is 6 into 5 by 2, which is 15. So it's a cool way of adding this. So first and last term, even in trigonometry, is one of the very basic ideas. So you can clearly see, like if I'll take j equals 1, right? So j equals 1 will give 1 cube over 2n plus 1 whole square minus 3 times 2n plus 1 plus 3 times 1 square. What about last term? If I'll take last term, we'll get 2n plus 1 whole cube divided by 2n plus 1 whole square minus 3 times of 2n plus 1 whole square plus 3 times of again 2n plus 1. But the second last term will be 2n cube. Okay, 2n whole cube. So as j runs from 1, 2, 3 to 2n plus 1, you can see if I consider j equals 1 and j equals 2n, they feel like counterpart of each other. So in that sense, if I consider j as b, a minus b can be a good way to, like attract this summation and to convert into a simpler one. Now it's not very difficult to evaluate this because we can write the given sum as b cubed by plus 3b plus 3b square, and this evaluates to a minus b whole cube by numerator is same, so that will give an answer of a cube minus b cube minus 3a square b plus 3, and now we are left with, so in the denominator we have a square minus 3b plus 3b square, and so now we are left with a common, a square minus 3ab plus 3b square, a square minus 3ab plus 3b square. So this gets cancelled and the answer is, and that was really surprising क्योंकि once if I'll take LCM, आप देख सकते हो इसका जो समीशन है वो फाइनली a बन के आ गया. तो इससे क्या एडवांटेज मिला? इससे एडवांटेज मिला जो वी कैन नाउ ऑब्जर्व द इनिशियल समेशन इज इक्विवेलेंट टू, बिकॉज फर्स्ट एंड लास्ट इफ यू वांट, so we'll display, because first is j equals 1 and last is 2n plus 1. So if you want first and last summation, okay, let it make it equidistant. So j equals 1 to 2n plus 1 j cube by 2n plus 1 whole square minus 3 times 2n plus 1j and plus 3j square. This we are writing as same as j equals 0 to 2n plus 1, because anywhere j equals 0 the sum doesn't gets impacted. The reason of writing this is now we have symmetricity in the system, right? Because first term, if I start with j equals 0 till 2n plus 1, I can see 0 and 2n plus 1 adds nicely, 1 and 2n adds nicely, okay, 2 and 2n minus 1 adds nicely, and hence we get our answer in a very good way. So the moment we do this, now this summation can be written as sigma j equals 0 to n, and by our previous result j cube by 2n plus 1 whole square minus 3 times 2n plus 1j, 2n plus 1 minus j plus 3 times 2n plus 1 minus j whole square. So it's kind of chain rule. It's kind of King's rule in action, right? Usually we apply King's rule in integration. So you see, like similar kind of ideas we have used, a plus b minus n kind of. Okay. Now why the limit of summation changes? So now why the limit of summation changes? Because j is from 0 to n. So the moment j is from 0 to n, so half of the summation will go, because we are going from 0 to 2n plus 1. So total we have 2n plus 2 terms. So half of them is there. So now this summation just takes the form of sigma. Because just sigma of a, so it's become sigma of 2n plus 1, right? Sigma 2n plus 1, where j is running from 0 to n as 2n square plus 10 plus 1. Okay. So this is yet to come in ये advanced, लेकिन आप clearly देख सकते हो जो this was a good problem based on basic ideas and how the interpolation of first and last term can be helpful. I hope you have enjoyed the lecture, and if you want to enroll in my course, you can see the link below in the description section. Thank you. Have a good day.